Hello, everyone. Before start, thank you for attending this session, and please keep your lucky draw ticket. End of this session, one single winner get a Note 10 Plus Aura Black, the Canadian Open Carrier package device. So let's start. I'm Junesig, and I'm working for Samsung Galaxy Game Dev team as DevTech engineer. This session is held by me and Unity David Berger. Hello. Have you heard that Samsung GameSDK or Unity's adaptive performance? It's okay if you don't know that. After this session, you will know well about the GameSDK and adaptive performance. I briefly introduce myself first. I've been working as a graphic software engineer for 6 years. And now I'm working as a Galaxy Game Dev team support developer for best performance of mobile game. When Galaxy Game Dev team did a lot of game collaboration through the game dev, game developer had many problems and questions. So Galaxy Game Dev team support game developers for these 4 areas. Game SDK and adaptive performance is one of solutions for these developers' problem. This session will cover Samsung Game SDK and Unity adaptive performance in detail. And we will also look at how adaptive performance is applied to actual Call of Duty Mobile. And if you want to know more information about the Samsung Game Dev's activity, then please join the Game Dev session. I will let you know that the Game Dev session info on end of this session. So now let's take a look at what you can do and how to solve the problem with the Game SDK. I will show you a short video. This video is from the same device and the same APK. Did you see that? What is the difference? As you can see that the FPS is different. So why does the performance difference occur the same APK and same device? Mobile had some limitation. First, mobile don't have active cooling system itself. So there are limited conditions that can prevent the heat itself. When running high-spec game in using high CPU and GPU frequency for the performance, and it raises up temperature. Temperature is exceeded a certain level, then summer throttling is happen for the prevent the rising itself. For reduced temperature, governor gradually decreased CPU and GPU power, so then result performance dropped sharply. The right graph shows that the difference before and after summer throttling. As you can see, FPS is dropped sharply and is not stable, and core frequency also gradually decreased. Second, mobile has a limitation of battery. So when the same performance, it is better to use less power. One way to reduce power is use lower CPU and GPU frequency, and it is also good effect for the temperature. Actually, this problem comes from the limitation of mobile. But developers don't have any information about the summer throttling and power control. That is real problem. So first, what about summer throttling in gaming? It means that you are in this situation. Game target FPS is 60, so it works fine at the beginning. But after a few minutes later, the FPS is gradually decreased, and end of FPS is 40. It's because higher higher frequency is allowed at the beginning time, and then summer degrees goes up quickly, and then summer throttling is happen. So if you know that the summer throttling timing, then you can do something to avoid this problem. But developer cannot know that the summer throttling timing, so they can do not do anything. So with GameSDK, you can detect the summer throttling timing. On high warning temp API is a listener function. With this API, you can detect the summer throttling timing through that warning level. So warning level 0 is temperature is low. And warning level 1 is that temperature has risen a certain level. This means summer throttling will be approached soon. So therefore, it is necessary to take action to reduce temperature of device. And warning level 2 means summer throttling is started. So with this API, you can detect summer throttling timing, so you can do something on your game. And GameSDK provided various temperature information. Each temperature information provided by abstraction level, and each temperature range is 0 to 7. So with this API, developer can know that the temperature trend. Second, what about power controlling in gaming? Do you have experienced this situation? Just a simple thing, but it looks like more used CPU and GPU frequency and power. So same performance, it is better to use lower power. So we should reduce unnecessary CPU and GPU frequency. But developer cannot control that CPU and GPU frequency. With GameSDK, you can control the CPU and GPU power in gaming. Set level with Scene API allowed you can control each CPU and GPU max frequency through that level. CPU level range is 0 to 6, and GPU level range is 0 to 4. So in this case, you set the CPU level 2 and GPU level 1, then you can control the CPU and GPU max frequency and reduce the unnecessary power. So now you can control the CPU and GPU max frequency. So how about this situation? When your game sets CPU level 1 and GPU level 1, and your game target FPS is 30, but your game running around the 28 FPS. So you should increase the CPU or GPU level. So if your game is CPU bottleneck, then increase CPU level. Or GPU bottleneck, you can increase GPU level. But you don't know that the bottleneck point. With GameSDK, you can predict bottleneck point. You can get n frames GPU frame time using get GPU frame time API. Using GPU frame time, you can predict bottleneck point. So in this case, you can predict, GPU bottleneck, so you just increase the GPU level. With GameSDK, you can get performance status and summer trend. So developer predict summer throttling and avoid performance degradation through that adjust game quality. Now, you can maintain and extend your game's performance. GameSDK is supported from Galaxy S10, Note 10, and Tab S6, and Galaxy Fold. And after Android Q upgrade, the Galaxy device will be supported, and Galaxy new device also will be supported. Although Galaxy GameSDK can be used by individual game developer, but we have developed adaptive performance in collaboration with Unity to make it easier and more convenient for many game developers who used Unity. So next, David will talk about adaptive performance package and Megacity demo.
Thank you, Junesig. Hello, everyone. Thank you. So hello, everyone. So it's really amazing to get all the data from the GameSDK, and it was really good to work with you guys, the Galaxy Game Dev team and Samsung together to get all the data from the GameSDK into a representative version in Unity to use it easily in your Unity games called adaptive performance. So we're gonna have a quick look and like how to get it, where to get it, and how to use it simply, and what exactly it does behind the scenes. Very quick introduction about me. I'm David Berger. I'm a software engineer for Unity Technologies. I worked there about like 5 years now, mostly optimizing games from indie developer, tiny one-man team games, up to AAA productions throughout the box in the last 5 years. And I'm mostly working on optimizing the Unity runtime. And one of the things we figured out during seeing all those optimization cases is that a lot of games on the mobile segment just struggle with all the information which is missing on the device, such as like all the things we just heard, thermal throttling events, not being able to control performance on CPU, GPU side, and a general information problem about timing. So we kind of tried to tackle that with Samsung and figure out a way to get it into Unity, and that's done via adaptive performance. So as we heard until now, it was not really possible to get throttle events or throttle timing, and there is not really enough time to actually react to those changes. And so just to kick things off, we partnered with Samsung to get the basic SDK data into Unity, but this is just the beginning. So we're gonna evolve adaptive performance into a more solid piece of work to get also improving the Samsung SDK to get more valuable feedback from the device, but a little bit to that later. So one of the things we had to figure out at the beginning was we needed a test case. And at that point, we just, at Unity, we just released Megacity, which is a desktop project we released, but we thought, well, it runs on desktop, so let's see how it performs on mobile devices. And we brought it over to mobile, and it works so-so. So we thought, well, that's the perfect case to test adaptive performance and see, does it actually make sense? Do we not do the right things? Is the feedback valuable or not? But why Megacity? So essentially what's happening in Megacity is it's a gigantic streaming world project released for desktop earlier this year. And we also released the mobile version for Samsung S10 with adaptive performance a couple of months back. And why this is a great demo project for mobile devices is we have around 8 million triangles we have to push from the CPU to the GPU. We have more than 6 million singular entities moving around and being processed during the demo. We have more than 100,000 audio sources, which all needs to get mixed and presented. And we have more than 2,000 AI cars driving around the city and try to do their thing. And this is all dynamically streamed in and out. And you might imagine that this is pretty hard and heavy for a mobile device to actually get done all that work. But it seems to be a great showcase to show what adaptive performance is able to do. It turns out at the end, well, it is a good showcase for CPU heavy work because it's mostly CPU bound. Not so good for GPU, but we got more demos and other game projects to actually show those cases. So what can be done with adaptive performance? For example, achieve 30 FPS stable over time in Megacity. Because without any specific optimizations, frame rate basically starts great, but it very, very fast cannot cope with the load of the system anymore. And in this case, the Samsung S10 goes into throttling after some time to protect its core, and the performance naturally goes down. And this is a typical scenario when you run mobile games. So how does adaptive performance now tackle that problem? As we heard before, it kind of is easy now to obtain the device performance status and the thermal trends. And as a developer, that basically now enables you to proactively adjust the performance and quality settings on the fly before the device actually throttles. But why is this useful, and what do we actually offer now? So just imagine if game developers know the timing of the thermal throttle event, they can try to avoid throttling altogether. So that's good for the device status in general. So they can tweak the performance and play around with the performance stats. So we introduced a couple of different stats. So we basically take the temperature warning from the GameSDK as is, and we also take the temperature levels and normalize those because it's a little bit more useful for the Unity developers within Unity to get our certain ranges. And then we created the temperature trend because for game developers it's usually more useful to know if the temperature is rising or going down without doing actually too much calculations. And it's easier for automated system and connect them within components in Unity. But we also played with GPU junction temperature, CPU junction temperature, and tried to figure out how useful those values might be to determine, for example, the bottleneck detection or refine bottleneck detection. So we're still experimenting with a couple of those features to enable or to make it slightly better. So as we've seen earlier in the slides, there is the temperature warning, and we have basically 3 states: no warning, imminent, and the throttling event. And that basically correlates exactly as the GameSDK does. So the imminent state basically means that the temperature of the device has risen above a certain temperature and level, and thermal throttling will occur soon if the temperature doesn't go down. So for a game developer, that now enables them to decrease quality or decrease workload, which is done on the CPU or GPU, depending on what's going on, to try to minimize the load on the device. And then hopefully be able to avoid the throttling event. So using the GameSDK, it kind of provides an abstract temperature level from 0 to 7. And we normalize that from 0 to 1. And we basically have the same curve as we've seen before. And in the back, we see megacity. So we have a slightly the temperature increase in there to see what would happen in the case when there is no optimization in the game whatsoever. Additionally to that, we see the temperature trend on, like you can imagine, seeing the temperature trend like that makes it slightly easier to scale back animations or streaming budgets or LODs or any other of the effects which are more dynamically created during runtime. But what else can be done to help adjusting the game quality without actually adjusting the content? And basically to extend battery life, reducing core frequency is the way to go. And by doing so, it will work towards avoiding the thermal buildup as well. So just imagine a main menu where there is not much going on, and you have your CPU and GPU full active, and you actually just waste battery because not much is going on in the game. So telling the game, well, actually, we don't need all that power, might be a good way to decrease battery, decrease the core frequency, decrease the drainage on the battery. That means as well, gamers can play the game longer, stay longer in your game. You make more money, we make more money, everyone makes more money. So it's a good use case. But at the same time, if you're going into the main game, you might want to increase CPU load because you're actually needing to stress the CPU more by loading content. In that case, you raise the CPU level, keep the GPU level down because there's still not much going on, and you, again, can save battery while getting the job done. And then you get into the game, there is maybe a more heavy area in the game, you just bump up the CPU, GPU load, and you gain the performance, and at the same time, you can average out the frame rate, and it gets more smoother, and it's a better play experience for the gamers overall. So to make that possible, we basically made a CPU and GPU level control component available within Adaptive Performance, which can change the CPU and GPU levels within 3 levels, because that's basically the low load, mid load, and high end load of the device, which makes it rather easy to understand and implement. So now one of the biggest issues in games is to know if one is CPU bound, GPU bound, or if you're actually reaching the target frame rate. And therefore, we get the precise timing of the GPU time. So knowing within Unity, we know exactly how our frame is composed and can take that time, use CPU time or GPU time, but because we get the GPU time from the GameSDK, and figure out, are we more CPU bound, are we GPU bound, or are we actually hitting the target frame rate? So now, as mentioned earlier, there might be the possibility that we're gonna improve that over time. Right now, it's a very simple process. But knowing the junction temperature might help or might not help to actually figure out if the CPU bounding is correct or if you're actually more GPU bound, although CPU load is higher. So this is some of the things we need to experiment a little bit and figure out what game type actually is affected more by that than others. So because every scenario is kind of slightly different. The good thing is adaptive performance is fully released open source, so you can just take the source. If you use it and you think that those values are actually not good for you, you can change it and figure out what's a good use case without actually tweaking too much on or being not able to do it because there would not be source code. So one additional feature we added to adaptive performance is the automatic performance control. So this is basically what we do in the Megacity demo, but we generalized that to make it possible to use it automatically by default without you actually doing any scripting to your game. So it basically says, well, we know the bottleneck, we know the temperature trend, and we basically take the CPU and GPU level to adjust the performance on the fly by performance feedback loop, more or less. So it's a very simple system, but the more we get from the GameSDK over time, more counters probably gonna increase the mechanic to that. But there as well, it's all open source. If you think you're having a better use case or you wanna adjust it on the fly, you can do so, or you just implement it yourself. So the API is fully transparent in that case. And we're gonna see later on how it's done in Megacity. And talking about Megacity, so what can we actually do about throttling and overtaxing the mobile device? So in Megacity, we basically use it in different ways. In the main menu, we set the low CPU and GPU level, as there is not much reason to keep it high. But when we switch into the game, we raise the CPU level slightly for the loading purpose. And after the initial loading, we decrease it again. And then, depending on the bottleneck, we're gonna increase or decrease the CPU and GPU loads to keep the energy consumption low, but the performance up. If we do not hit the target frame rate, we have the possibility to change the LOD BIOS or the streaming budget and figure out a way to reduce the load there. And if we still would not come close, or if we still get into a state where we get close to a throttling event, we decrease the frame rate so that we can also lower CPU and GPU load at the same time and avoid the thermal overkill. So the big question is now, did it work? Well, I'm here, so it kind of worked. So you see frame rate before in red, just dumping down. But in blue, we see the actual frame rate with adaptive performance turned on. So you see at the beginning, it's pretty much the same because the workload has always been the same, except we're actually saving now battery. And then in the later state, we can keep the 30 FPS way longer stable at 30 FPS, and only when we get into a more dense area of the game, we have to lower the frequency, the FPS to 28, and be able to avoid the thermal overkill on the device completely. So one day when we implemented it the first time, I went to bed and forgot about the device. The next day I came back to my workplace. The game was still running smoothly at 28 and 30 FPS without problem. So even after 8 hours of just running, obviously connected to the power, it still was working properly. So let's see how this looks visually. On the left side, we see adaptive performance on. On the right side, we see adaptive performance disabled. And we basically see at the beginning it's very similar performance. And we have similar LOD levels. You see the same kind of cars. You see the LOD popping is slightly more on the adaptive performance side because the performance starts to leverage out, so our system tries to work against that. But we also set the CPU and GPU levels way lower on the adaptive performance side in this part of the level, which sure keeps the FPS slightly less, but overall, when we see in the next scene, adaptive performance is able to maintain that FPS rate, while the one without, in this case, we see that without adaptive performance, the performance just crashes down, while with adaptive performance, we can keep up the FPS and even get it slightly higher again to our workload by increasing the CPU level. So now, that basically shows that there are effects on the traffic and LOD system because we choose so, but depending on game, you can do other things like decreasing the visual effects, figuring out like what's happening on like the AI side. There are tons of features, and it really depends on the game what can be scaled down and scaled up and can react to the thermal events or tries to prevent the thermal events. In this case, Megacity is just such a diverse system having so many objects present that it actually doesn't feel like there is a big difference because the eye just sees so many objects at the same time. So it's really not that problematic to scale down the object generation or the car generation. But it really depends. I mean, this is just a tech demo. It's not a real game. So it kind of doesn't show any gameplay effects or things you usually have to deal with in actual games. But it shows very well what adaptive performance is capable of and that the system worked the way we hoped it would. So knowing the thermal trends now and states within the device lets the developer basically aim for maximum quality and maximum performance, resulting in a way smoother gameplay and in most times also in a more stable frame rate, while still having a lower impact on the energy side. So your gamers can play longer. Adaptive performance is basically available right now for Samsung S10, Note 10, and for all future Galaxy devices. As well, once Android Q update is launched, all Galaxy devices with Android Q update gonna be supported as well. So let's see how adaptive performance can be integrated. If you know Unity, you might know that there is a package manager. It's very simple. You find the adaptive performance sensor, Samsung Android provider. You just press install, and it's going to install the Samsung package as well as the main adaptive performance package. And with that one click, it gets integrated into your game. It's activated, and as soon as it's deployed to your device, it's all active and already helping you to save performance. If you choose so, you can also enable logging, so you see immediately what's happening on the device. Additionally, you could also just install the main adaptive performance package, which won't work then on an Android device, but there might be reasons you want to have your own provider or server which actually manages your database of tiers you had before. We also work on a simulator, which gonna be added in a preview package in the next couple of weeks, so you can test all your gameplay elements by using the device simulator of Unity, so you don't actually have to deploy it to a device to test within your editor game what the effects are if you go into throttling mode or get temperature values in a certain range. So how to use it? It's basically to make optimization, you simply add a monobehavior script to access the Adaptive Performance Manager with the iAdaptive Performance interface and subscribe to events of interest, such as the thermal events, the bottleneck events, or as we see in Megacity, for example, we start in the menu scene, so we get the device performance control, set the CPU and GPU level to 0, and that's pretty much it. And then when we go into game, we just set the CPU and GPU level to whatever is appropriate. So seeing that within Adaptive, with Megacity, you can also subscribe to thermal events, which tells you, well, in Megacity, we set the target frame rate to 30 if nothing is happening. If we get the throttling imminent event, we choose to go to 28 FPS. And then if there is a throttling event, we set it to 15. Now, between you and me, and everyone else on the internet now, setting it to 15 FPS doesn't really make too much sense if you're already in the throttling state, because the GameSDK and the Samsung device actually does a way better job by reducing the correct resources than setting it to 15 FPS. So in that case, you can basically just ignore it. But in your game, you might have a different scenario. In case of the performance events, when we are either a GPU or CPU bottleneck, we figure out, can we still raise CPU or GPU level and do that, or we lower the LOD depending on the timing or what's still possible on the device or where we are in the scene. In the case you're target frame rate bound, it basically means, well, you reach your target frame rate, you can start lowering CPU and GPU levels to save power, or you can raise the LOD levels or effects or anything towards that area. But generally, that's how you can use adaptive performance. And that's pretty much it from my side. So thank you very much for listening, and I'll give over to you.
Thank you. We look at how to use GameSDK and adaptive performance and Megacity demo in detail. Now we will look at how adaptive performance is applied to actual Call of Duty Mobile. Before starting, let's look at the Call of Duty Mobile video. So let's take a look at adaptive performance in Call of Duty Mobile. First, quality scale factor will adjust through that power management and temperature trend and thermal throttling information. Quality scale factor are shadow distance and foliage LOD, animation LOD, and target frame rate adjustment were applied. And power management is working with the minimum CPU and GPU power budget. Dynamic control was performed by bottleneck detection of the current frame. Let's look at the quality scaling factor in detail. In high-fidelity mobile game, wheel-based thermal throttling, even using adaptive performance power management. Therefore, additional quality scale factor must be required. As you can see in this table, this scaling factor didn't much impact CPU and GPU power, but it can reduce thermal by adjusting before the thermal throttling. Actually, we asked for many scaling factors, but it is not suitable for the game environment, so they decide to apply only the following quality scaling factors. This table and graph are performance comparison with adaptive performance and normal version. As you can see, in the following table, the performance with adaptive performance is more stable and FPS is higher. Median FPS improved 7% from the 54 to 58. So, how adaptive performance get better performance data? Let's take a look at temperature and power data. In the temperature graph, with adaptive performance case, temperature is average 2, maximum 3 degrees lower than without adaptive performance. Also, frequency graph is showing CPU frequency is managed lower and GPU frequency is keeping as a stable level. Normal version case use more CPU frequency at the beginning time, so it quickly meets summer throttling, and after that, FPS is dropped, and power control also shaking. For this reason, adaptive performance, temperature, and performance are much better than normal version. So we can make sure there is clear benefit of the adaptive performance of real game Call of Duty Mobile. We look at how to use GameSDK and adaptive performance and clear benefit. And I last level with summary in this session. Can you recognize that a big difference on this GIF image file? Some quality scale factors have a very good off-roading effect with a low visual impact. And console, like Xbox and PSV case, quality scale factor is commonly used. As you can see following table, this quality scale factor can save much GPU usage with low visual impact. If game developer and user much care about the visual detail, it will be difficult to change the quality scaling easily. However, if you want to maintain performance without summer throttling and provide a stable gaming experience with a suitable visual quality on mobile, then GameSDK and adaptive performance are best solution. So that's all for me today, and we have a bunch of sessions about the gaming in SDC 19. AR Image SDK session is already done. Remaining game sessions are Game Booster, Game Performance Index, and Game Dev 2 session. Game Booster session will be tomorrow 1:30 p.m. at room 120B. This session introduces basic concept and how to connect to Game Booster from the developer point of view. And Game Performance Index will be tomorrow 3 p.m. at session room 211A. This session will cover that new generalized framework for measuring the performance of mobile. And this session information from the Galaxy Game Dev team. First, after this session, Galaxy Game Dev bring maximum boost to mobile game 2 session will hold on room 210D. If you attend this session, you can know that the Galaxy Game Dev's new activity and program, and we will introduce a new partner practice. And tomorrow, 2:30 p.m., vulcanized mobile game optimization technique will hold on room 211A. This session will cover how to Galaxy Game Dev optimize performance on mobile game and vulcan technical case. Please join all the session to see what happened in Samsung Gaming support, and don't forget the lucky draw event at the end of each session. And we are operating CodeLab and Boost table on Tech Square. On CodeLab, you can learn how to use adaptive performance for the Mega City demo and modified and change game performance and quality scaling factor in code level, and you can also see the performance result. And our Boost can get more information, Galaxy Game Dev's activity, program, and Vulkan in detail. Please join our CodeLab and Boost also. Please feel free to contact and question our email, and also come to our booth and CodeLab. And if you have any question and request adaptive performance and GameSDK, please contact gamedev@.com, samsung.com, and db@unity3d.com, and visit Galaxy Game Dev landing page, developer.samsung.com, and /game. So now Let's lucky draw time. Do you have lucky draw ticket? Yes. Okay. One single winner will get Note 10 plus Aura Black Canadian Open Carrier Package device.
Let's see.
Device.
Who's the lucky winner? I got one ticket. And the lucky winner is 106. 106. Ooh, awesome. Come on over. So for everyone else, thank you for joining. Have a good event. And if there are any questions left, we're still having a couple of minutes left to answer them, or just email us. So thank you very much.
Thank you.